Welcome to rational functions. What is a rational function? Well, a rational function is a polynomial divided by a polynomial. So you have a polynomial up here we'll call p of x, and I have a polynomial here which we'll call q of x. So I can tell if it's a rational function if it is a fraction. So basically you're looking at a fraction. And because it's a fraction, we all know that the denominator cannot be 0. So because the denominator cannot be 0, there's different kind of properties that happen with a rational function, and they give rise to something we call asymptotes. Okay, so a vertical asymptote is a line that goes like this, and it's x equals a number, and a horizontal asymptote looks like this, where it's y equals a number. And basically an asymptote is, I call it like an electric fence, is that it's your function gets very, very close to it, but it never, ever, ever touches it. So, and they call it an asymptote. That's how you say it. This L stands for the limit, and we talked about limits earlier this year, that this is what your function is approaching, your y values are approaching. So it's a line, and it also can be discussed as a limit, as you'll see later on. Let's talk about vertical asymptotes. So first of all, we have this rational function, here it is right here, and we want to find the vertical asymptote. Well, you find the vertical asymptote by determining the values of x for which q of x equals 0, which is what I alluded to earlier, your denominator cannot equal 0. So when we want to do our vertical asymptote, we basically want to make sure that we take our denominator and put it equal to 0. And when I do that, I'm actually going to solve for a line, okay, that has where it doesn't touch. So it's going to be an x equals line. It's going to be x equals a number that your function doesn't touch. Okay? So this is zeros in, in the denominator. You could have more than one asymptote too. So here's a vertical asymptote, zeros in the denominator. That's how you determine it. Horizontal asymptotes, which I showed you in the slide before, okay? Horizontal asymptotes, you're going to use your numerator and your denominator to find, all right? So this is going to give you a y equals a line. You can have more than one too, all right? And this is your horizontal asymptote, or your y equals your limit. Now, the next slide is going to tell you more, because there's 3 cases that you can use to find your horizontal asymptote, and we're going to talk about that, right? Your x-intercepts. How do you determine your x-intercepts? Your x-intercepts are a number, 0. It's where it crosses the x-axis, okay? So because this, you're going to put your f of x equal to 0, or your y equal to 0, if you will. So that's how you tell your x-intercepts, is that you make your y equal to 0, and that will give you your x-intercepts. And these are points. I want you to make sure that these are points. So you're going to have a number 0. In these 2 cases, the vertical asymptotes and the horizontal asymptotes, these are actual lines. So this is a line, this is a line. That is why you're going to have a y equals and an x equals. Here you're actually going to tell me what it is in a point. Y-intercepts is 0, a number. So this is where you're going to have your x equal to 0. And when you have your x equal to 0, you're also going to get points on this one also, and it's going to be 0, a number. And this is where it crosses the y-axis. Okay, so I have this function here, and actually I wrote it here and graphed it here. So this is the function. We'll write it over here. I've got y equals, or f of x equals, 3x squared minus 12 over x squared minus 1. Okay? And we're going to go through and do all the 4 things that we just talked about. We're going to do the vertical asymptote, the horizontal asymptote, and they don't have to always have them, but I want you to have the the column for it. So we'll use VA for vertical asymptote, HA for horizontal asymptote, x-intercept, and y-intercept. And then you'll see how by looking at the function you can kind of look at the graph. Okay? So vertical intercept, how do we do that? Well, that's when you put your denominator equal to 0. Your horizontal asymptote is you're going to use your numerator and your denominator. We talked about that before. Your x-intercept is a number 0, and your y-intercept is 0, a number. Okay? So vertical asymptote, we're going to take the denominator and put it equal to 0, and when I factor this, I have x equals a -1 and x equals a 1. Okay? Now, those are vertical asymptotes. They're actual lines. And if you look at your graph here, you can see here, it's kind of skinny here. And we usually use a dotted line. But right here is x equals 1. And right here is x equals -1. Now, I know that your notes might not match this, so you might need to stop the slide and draw the picture. But right there are my vertical asymptotes. And I leave them, they're lines, so these are my answers. So I have more than one. Okay, your horizontal asymptote, we're going to talk about more of this on this next slide, but you basically take your highest power of your function. So I'm just going to look at the 3x squared only divided by the x squared and see how the powers match. You don't need to look at the rest of it. Just for the horizontal asymptote, you just look at the highest power, and then we're going to cross those out, and so it'll be 3 over 1. So your horizontal asymptote is y equals 3. Now we're going to show you the 3 cases. That's just one of the cases, is when the powers match. And if you were to look at your graph here at 1, 2, 3, sorry, it doesn't. At y equals 3 here is your horizontal asymptote. It looks like it's approaching that, but never really gets there. Okay, so now I have vertical asymptote and horizontal asymptote. X-intercept, I take this graph and I'm going to have a number 0, so wherever y is 0, so I'm going to say 0 equals 3x squared minus 12 all over x squared minus 1. And you can cross multiply if you want. And when I do that, I have, okay, I put this equal to there, and I said, okay, if I put it equal to 0, if I cross multiply, I really have 3x squared minus 12 equals 0. So if I cross multiply, see how the bottom disappears here? And then I got 3x squared equals 12, x squared equals 4, and you got to remember when you take the square root, it's plus or minus 4, so x could be a positive 2 or negative 2. But you can't leave it like that. It's 2 points, so it actually crosses at the point 2, 0 and negative 2, 0. I want points, and if you look at it, it here does cross at 2, 0 and negative 2, 0. So we did that right. It's kind of running out of room here. Whoops, sorry. Let's go back up. Back down, I guess. Sorry. Okay, so now the y-intercept is where I put x equals 0. So I'm going to say, okay, 3 times 0 squared minus 12 all over 0 squared minus 1. So I have negative 12 over negative 1, or 12. Okay, so y equals 12. So my point is 0, 12. And does this cross? Let's look at this. 1, 2, 3, 4, 5, 6. Oh, these must count by 2s. 2, 4, 6, 8, 10, 12. Yes, so this is the point 0, 12. Okay? So now we found everything we needed here. Now, not every function is every rational function is going to have all of this. It might have all, or it might have some. I just wanted you to see that I picked one that had everything. Okay? So here are the 3 cases I keep talking about. If you have 3 cases for, this is finding the horizontal asymptote. So I'll give you an example with each one. Okay? So one of them is if the degree on, so before, let's kind of look at this, how we had this function set up. We had p of x over q of x. See how that was? So I've got p of x, if it lets me right here, p of x over q of x. So here's my rational function, okay? If the degree in the numerator is less than the degree in the denominator. So if I had something like this, 3x over 4x squared. See how the power When they say degree, they're talking the power. See how the power is smaller on the top? When it's like that, I know my horizontal asymptote is y equals 0. So you have to memorize this, okay? Here, if my degree on the top, my numerator, is greater than the degree on the bottom, on the denominator, so if I had 3x squared over 4x, see how the power on the top is larger than on the bottom now? Then there is no, so there is none. No horizontal asymptote. You don't have to have one. Remember what I told you. So I guess the way I remember this is if the power is smaller on the top, I know it's y equals 0 because that can't go in here. Here, this x can go into that x squared and kind of disappear, so that's why I don't know how you want to remember it, but there is no horizontal asymptote. You have to memorize these cases. The one that you saw on the slide before is when the degrees equaled. So if I had 3x squared over 4x squared, and it's only the highest power, if they match, you can say thanks for playing, so my horizontal asymptote is y equals 3/4. This is my favorite one because you can cross off and say thanks for playing. So you need to memorize these three cases, y equals 0, none, and then y equals the one where you cross them out. Okay, so let's practice some. On this next slide, I've got 4 functions here, and we're going to do them all here, so we're going to set them all up first. So I have vertical asymptote, horizontal asymptote, x-intercept, y-intercept. And let's set them up for all of them, okay? So then when we do this, we can just put them in the columns. And you can actually graph these, because I had someone one year said, well, I can graph and look at it. I said, you're absolutely right, but now you're showing the algebra behind it, and they're all characteristics of rational functions, so that's why I'm showing you how to do this. So once we get them all set up, all our 4 columns, we can go through and do this. Now recall, vertical asymptote is denominator equals 0. Horizontal asymptote is your numerator and denominator, the 3 cases. X-intercept is a number 0. Y-intercept is 0, a number. So that's going to be with all of them. I'm not going to write that on each one of them. So if I take the denominator of this one and put it equal to 0, I got x equals -1, and that is my vertical asymptote. Okay, my horizontal asymptote, I take the higher power of the 2, so it's going to be 3x over x. I don't care about the rest. They happen to match, so I have y equals 3. So that does have a horizontal asymptote. That's case 3 where the powers matched. The x-intercept here, let me erase this so we'll get the circle all the way, is when I put a number 0, so I'm going to put 0 in for y, so I have 0 equals 3x minus 2 all over x plus 1. If you cross multiply, the bottom disappears, so you have 3x minus 2 equals 0, so x is going to equal 3/2. So the point is 3/2, 0. Don't forget to show it as a point. Okay? The y-intercept is when I have zeros in for x's, so I have 3 times 0 minus 2 over 0 plus 1, and so it's -2, so the y-intercept is 0, -2. So now this one had all 4. We found them all, right? Now if you want to stop this and practice the next 3 and then come back and I will show you how to do this, or you can follow along with me, okay? Next one, vertical asymptote is denominator equal to 0, so I have x squared minus 4 equals 0, x plus 2, x minus 2 equals 0, so I have x equals -2, x equals +2. This one has 2 vertical asymptotes. Horizontal asymptote is I take the highest power of the 2, so I'm going to do the 5x squared over the x squared. They match, so I can say thanks for playing. So my horizontal asymptote is y equals 5. Okay. My x-intercept is a number 0. So I'm going to put in 0 for y. So when I do, I have 0 equals 5x squared plus 1 over x squared minus 4. And when I cross multiply, the denominator goes away. And then I have 5x squared plus 1 equals 0, 5x squared equals -1, and then I stop and say, there's no way that I can have 5 times something squared be negative. So this does not work. There is none for the x-intercept. That means it doesn't cross the x-axis. That can happen. There is none. The y-intercept is 0, a number. So I'm going to put 0 in for x, and when I put zeros in for the x's, I really get 5 times 0 squared plus 1 all over 0 squared minus 4. So it's negative 1/4. Y equals negative 1/4. I put negative 1 over y. So your y-intercept is 0, negative 1/4. Remember, I told you need to write it as a point. All right, nice. Okay, let's try the next one. Vertical asymptote. Denominator equals 0. So I say, sorry about that, x squared plus 1 equals 0. And I can't factor that, and if I move it over, I have x squared equals negative 1. Never will anything squared be negative, so there is none. Horizontal asymptote, I have to use the numerator and denominator highest power, so I've got to use the 2x and the x squared. So I have 2x over x squared. Now this is the case where the denominator is larger than the bottom, so this one, I memorized it, is going to be y equals 0. No math to do, just you need to know that the power on the denominator is larger. X-intercept is where y is 0, and I have 0 equals 2x over x squared plus 1. When I cross multiply, I have 2x equals 0, or x equals 0, so my point is 0, 0 is my x-intercept. It crosses right at the origin. Y-intercept is where it's a number, 0 a number, so I can put 0 in for x. So I have 2 times 0 over 0 squared plus 1, which is 0 over 1 or 0, so y equals 0. So again, the y-intercept is the origin, and that makes sense because it is the x-intercept and the y-intercept. And the last one, vertical asymptote. Denominator, x minus 1 equals 0, x equals 1, so there I have a vertical asymptote. Horizontal asymptote, I use the numerator and denominator, there it is. So I have a negative x squared over x, and the power on the top is larger, so when I do that, there is none. That was one of the 3 cases. X-intercept is when we have 0 in for y, so I say 0 equals 3 minus x squared over x minus 1. When you cross multiply, so I have 3 minus x squared equals 0, x squared equals 3, x equals plus or minus radical 3. So my points are, I'm going to come over here a little bit, radical 3, 0, and negative radical 3, 0 are my 2 points. And the y-intercept on this one, is when x is 0. So I'm going to say 2 times 0 over 0 squared plus 1. 0 over 1 is 0, so y equals 0. So it's the point 0, 0 is where the y-intercept is. Did I do that right? Yes. Okay. So there you have it. Now I have given you all that. Now, I just want to do one where we go backwards because this is the tricky part. So if I give you a function, you should be able to go backwards and say, oh, I know what this formula is. So I look at it and say, it looks like it has a horizontal asymptote here, and it looks like it has a vertical asymptote. So the first thing I do is look at the roots. So I know it's going to be f of x equals, and it's going to be a rational function, so I have a fraction. And the vertical asymptote is what gave us the denominator. So it looks like there's a vertical asymptote at x equals 1 and x equals negative 1. So you have to say, okay, it's x equals 1, x equals negative 1. If that's what I found out, what was there to begin with, so I know that x plus 1 times x minus 1, if I put that equal to 0 and solve it, I would get these two things. So you're like working backwards. These are my vertical asymptotes. What was it before that? Okay? This is really, if you were to multiply it out, x squared minus 1. Now, I want to do the horizontal asymptote, and the horizontal asymptote, I look at it and say, well, jeepers, I'm not for sure, but I do see there's some roots here. Looks like it crosses at 2 here and at 2 here, so I know this is the point 2, 0, and this is the point negative 2, 0, so if I let my y be 0, remember how the bottom kind of disappeared? So I say, oh, the top must be x plus 2, x minus 2 to get those 2 points. Okay? So now I've taken care of the roots. I've got the vertical asymptote. Now the other thing is I got to find out, okay, where is this crossing? And it looks like 1, 2, 3. It's not really crossing, but it looks like it has a horizontal asymptote at y equals 3. So if I multiplied this out, it'd be x squared minus 4. I have to make sure that if I'm going to do the numerator denominator to find the horizontal asymptote, that it has to be a 3. So I'm going to stick a 3 in front of that, so that when I get this, I end up getting this function 3 times x squared minus 4 all over x squared minus 1. And that would be f of x equals 3x squared minus 12 all over x squared minus 1. And if you look at it, see, if I were to do the horizontal asymptote, they would cancel out. I'd get the y equals 3. I'd get my 2 vertical asymptotes. And if I plugged a 0 in here, I'd get a 12, because this is where it's crossing up here at the point 0, 12. So everything works. I've kind of worked backwards to say this is what a potential formula for this function could be. So that's it. We're going to practice more going backwards in class too, so that concludes this video.